March 1943. Somewhere in the Aleutian fog, a Navy radio man yanks off his headset and swears. He's been listening to the same garbled transmission for 20 minutes. Japanese voices buried under atmospheric static so thick it sounds like the ocean is inside the radio. He knows there's intelligence in there. Convoy positions, maybe. A submarine heading toward Dutch Harbor. But the words are drowning. He rewinds the wire recorder, plays it again. Nothing, just hiss and fragments. And that's when he realizes the enemy they can't decode isn't speaking in cipher. They're speaking in sound. This wasn't supposed to be the hard part. By 1943, Allied cryptanalysts had cracked German Enigma, broken Japanese naval codes, and built entire intelligence operations around the idea that if you intercept a message, you can read it. But there was a second war happening in the airwaves, one that didn't care about codebooks. It cared about clarity, about whether a linguist in a freezing Quonset hut on Attu Island could hear the difference between a Japanese officer saying, "Prepare to advance," or "Return to base," through a storm of ionospheric interference, equipment noise, and the low howl of a carrier wave that had traveled 3,000 miles across the Pacific. The problem wasn't encryption, it was audibility. And in war, if you can't hear the order, you can't stop the attack. Before we go further, take a second to subscribe, because every week we uncover the invisible wars, the signal, hunters, and the machines that pulled meaning out of noise when entire operations hung on a single decoded word. The Allied listening network in 1942 was massive and fragmented. Stations stretched from Iceland to Australia, from the cliffs of Cornwall to the jungles of New Guinea. They intercepted everything: Morse, voice, teletype, encrypted bursts. But voice intercepts, raw speech transmitted over shortwave or VHF, were the hardest to process. You couldn't run them through a bomb machine. You needed a human ear, and more than that, you needed an ear trained to pull apart dialects, accents, and regional speech patterns that most Americans had never heard before. The Office of Strategic Services and the Signal Intelligence Service knew this. They'd been recruiting linguists since before Pearl Harbor: Japanese Americans from the West Coast, German refugees, Italian émigrés, Polish scholars, Chinese interpreters. By mid-1942, there were language schools at the Presidio in San Francisco, at Camp Ritchie in Maryland, and inside requisitioned colleges across the country. The students learned vocabulary, syntax, slang, military terminology. They drilled on speed and accuracy, and then they were sent into the field, handed a pair of headphones and told to listen. But the field didn't care how fluent they were. The field was a tent on Guadalcanal, where the humidity corroded equipment faster than it could be replaced. It was a frozen bunker in the Aleutians, where generators coughed black smoke and radio receivers picked up more aurora interference than enemy transmissions. It was a truck bouncing through the Apennines with a tall antenna swaying in the wind, and a sergeant shouting over the engine noise that they had 5 minutes to intercept a German artillery net before it went silent. And in all of those places, the linguists heard the same thing: nothing, or worse than nothing, something that might be a word, buried in static. The technical problem was this: radio waves degrade. They bounce off the ionosphere, scatter through weather fronts, get distorted by terrain. A transmission sent from a Japanese destroyer near Truk Lagoon might pass through a tropical storm, refract off 3 different atmospheric layers, and arrive in the Aleutians as a faint, warped signal barely stronger than background noise. Add to that the limitations of 1940s radio equipment: vacuum tube receivers with narrow bandwidths, crude filters, speakers that rattled at high volume, and you had a system that was as likely to destroy intelligibility as preserve it. Linguists complained. Reports came back from the Pacific, from North Africa, from England. The messages were blunt. "We know there's speech in the intercept. We can't hear it well enough to translate it." Some estimated that 40% of intercepted voice traffic was too degraded to analyze. Others said it was higher. In a memo dated October 1942, an intelligence officer in Brisbane wrote, "Our Japanese linguists are excellent, but they are not magicians. If the signal is 10% voice and 90% noise, there is nothing to translate." Washington took this seriously, because voice intercepts weren't just supplementary intelligence. They were often the only real-time intelligence. Encrypted messages could take hours to break, sometimes days, but voice traffic was immediate. A pilot radioing coordinates, a naval officer issuing movement orders, a logistics unit calling for fuel. If you could hear it and understand it fast enough, you could act on it. Redirect a bomber group, reposition a submarine, warn a convoy, but only if you could hear it. The first attempts to solve the problem were mechanical. Engineers at Bell Labs RCA and within the Army Signal Corps started designing filters, circuits that could isolate specific frequency ranges and suppress noise outside of them. The racking theory was simple. Human speech occupies a relatively narrow band, roughly 300 to 3400 hertz. Everything else, static, hum, interference, could theoretically be filtered out. The reality was harder. Early bandpass filters worked, but barely. They reduced noise, but they also muddied the speech, flattening vowels and smearing consonants. A Japanese word that relied on tonal precision, or a German command that hinged on a single phoneme, could become unintelligible. Linguists tested the systems and reported back, better than nothing, but not good enough. Not if you needed to distinguish between iku and go and iru exist, or between Feuerfrei in fire at will and Feuer ein, ceasefire. What they needed wasn't just less noise, they needed clarity, and clarity required something more sophisticated than a simple high-pass filter. That's when the engineers started thinking about the human ear. The human auditory system is an extraordinary signal processor. It doesn't hear all frequencies equally. It's most sensitive to the range where speech lives, roughly 1000 to 4000 hertz. It can extract a voice from a crowded room, distinguish between speakers, and reconstruct meaning, even when parts of words are missing. It does this through a combination of frequency filtering, temporal processing, and psychological inference, what linguists would later call top-down processing. You don't hear every phoneme perfectly. Your brain fills in the gaps, but radio intercepts didn't allow for gaps. There was no context, no visual cues, no second chance to ask for clarification. The linguist had to hear it right the first time, or the intelligence was lost. So the engineers began designing filters that mimicked the ear's sensitivity curve, what's now called a weighting filter. These devices didn't just cut out noise, they shaped the frequency response to match the way human hearing naturally emphasizes speech. Bass rumble and high-frequency hiss were attenuated more aggressively. The mid-range, where consonants and vowels carry the most information, was preserved and slightly amplified. Bell Labs built one of the first prototypes in early 1943. It was a multi-stage vacuum tube circuit housed in a steel box the size of a car battery. It sat between the radio receiver and the headphones, processing the signal in real time. The unit was shipped to a listening post in the Pacific for field testing. A Japanese linguist put on the headphones tuned to a known enemy frequency and listened. For the first time in months, he could hear the words, not perfectly, not like a studio recording, but clearly enough to distinguish phonemes, to catch verb tenses, to separate one speaker from another. The filter didn't remove all the noise, it redistributed it, pushed it into the frequencies where speech wasn't, leaving the voice intact. It was a trick of perception as much as engineering, but it worked. Word spread fast, more units were built. Variants were designed for different conditions, filters optimized for shortwave propagation, for VHF line of sight, for intercepts recorded on wire and played back at reduced speed to catch fast-talking radio operators. The Office of Strategic Services and the Signal Security Agency began equipping listening posts with these devices as fast as they could be produced. By mid-1943, nearly every major intercept station in the Pacific and Europe had at least one. But the filters alone weren't enough, because the second problem, just as hard, maybe harder, was the language itself. Japanese military radio operators didn't speak standard Tokyo Japanese. They spoke regional dialects, service-specific jargon, and rapid-fire abbreviations that even native speakers struggled with. A naval officer from Hiroshima sounded different from an army sergeant from Kyushu. Technical terms were borrowed from English, and German, mangled through Japanese phonetics. Numbers were spoken in archaic military style, dates used the imperial calendar, and some transmissions were deliberately obscured with code words that weren't in any dictionary. The same was true for German intercepts. A Luftwaffe pilot radioing from a Focke-Wulf over the North Sea used slang and acronyms that wouldn't appear in a textbook. A Wehrmacht signals officer coordinating artillery fire in Italy spoke a clipped technical German full of abbreviations and map grid references. and Italian transmissions were a nightmare of regional accents, Sicilian, Neapolitan, Tuscan, layered with naval terminology inherited from a dozen different historical sources. The linguists had to learn all of it, and they had to do it under pressure, in real time, often from a single degraded intercept that might never be repeated. Training programs, adapted. At the language schools, students were drilled not just on grammar but on listening. They were given recordings of native speakers, sometimes actual intercepts, sometimes simulated, and told to transcribe them. The recordings were deliberately degraded. Static added, volume reduced, speed increased. The idea was to prepare them for the field, to teach them how to hear through noise, how to infer meaning from fragments, how to recognize a speaker's region or service branch from cadence and vocabulary alone. Some students washed out. The cognitive load was enormous, holding incomplete sentences in working memory, cross-referencing dialect variations, making split-second decisions about ambiguous phonemes. But the ones who made it through became some of the most valuable assets in the Allied intelligence apparatus. They weren't just translators, they were signal interpreters. They could take a broken, static, choked transmission and extract not just the literal words but the intent. By late 1943, the system was working. Linguists with filtered receivers were catching Japanese convoy orders in the Central Pacific, German bomber formations over the Mediterranean, Italian naval movements in the Adriatic. The intelligence was fragmentary, but it was actionable. A single intercepted sentence, refueling at dawn, proceed to grid 12, could mean the difference between a successful ambush and a missed opportunity. And then the engineers took it a step further. They started building voice analysis tools. These weren't computers in the modern sense, but they were the ancestors of spectrographic analysis, machines that could visualize sound. The concept was borrowed from early acoustic research. If you passed an audio signal through a series of tuned resonators and photographed the output, you could see the structure of speech, the frequency components, the harmonics, the gaps between phonemes. Engineers at the National Defense Research Committee and the Radiation Laboratory at MIT began experimenting with these devices for intelligence work. The machines were crude, mechanical filters driving galvanometers that scratched traces onto smoked glass or photographic paper. But they worked. An intercept that was too noisy to understand with the ear alone could sometimes be read on the spectrogram. A linguist could see where the vowels were, identify the I, consonant clusters, reconstruct the word even if the audio was nearly inaudible. This technology didn't replace human linguists. It supplemented them. In cases where an intercept was on the edge of intelligibility, the spectrogram could tip the balance. It turned listening into a hybrid act, part auditory, part visual, part forensic analysis. By 1944, these systems were in use at major intercept centers in Hawaii, Australia, and England. The workflow looked like this. An intercept came in, often recorded on wire or lacquer disc. A technician played it through a filtered receiver, while a linguist listened and transcribed. If the intercept was too degraded, it was sent to the voice analysis section. There, an engineer ran it through the spectrographic device, producing a visual trace. The linguist examined the trace, identified phonemes, cross-referenced with known vocabulary, and produced a translation. The entire process, from intercept to finished intelligence report, could take less than an hour, and it saved lives. Pilots were rerouted away from ambushes. Convoys changed course to avoid submarines. Ground units received warnings about enemy movements hours before contact. None of it was perfect. Intelligence never is. But it was faster. And in war, speed is survival. Because the third layer of the problem, the one that didn't show up in the training manuals, was verification. A linguist could hear a word, transcribe it, and still be wrong. Not because they didn't know the language, but because context was missing. A Japanese transmission might say Teki no Ichi, enemy position, but without knowing which enemy, which position, or which unit was reporting. The intelligence was incomplete. And in a theater as vast as the Pacific, incomplete intelligence could be worse than none at all. It could pull resources toward a phantom threat while the real one slipped through unnoticed. So the Allies built voice libraries. Starting in 1943, listening posts began recording and cataloging not just what was said, but who said it. Every intercepted transmission was logged with metadata, time, frequency, signal strength, direction of origin. And if the same voice appeared multiple times, it was tracked. Analysts gave them designations: Target Victor 12, Tango 9er, and built profiles. They noted speech patterns, favorite phrases, procedural habits. A Japanese naval officer who always signed off with a specific honorific. A German bomber pilot who used the same call sign across multiple missions. An Italian coast watcher who had a distinct Sicilian rasp. Over time, these profiles became intelligence assets in their own right. If Victor 12 was a known convoy commander, and his voice suddenly appeared on a new frequency, that meant something. If Tango 9er, a Luftwaffe squadron leader, was heard coordinating with ground units, it suggested air-ground operations were imminent. The voices became signatures, as identifiable as a fingerprint, as predictable as a code. The technology to support this was primitive by modern standards, but ingenious for its time. Wire recorders allowed segments of speech to be saved, replayed, and compared. Linguists kept binders full of transcriptions, cross-referenced by voice ID, unit, and theater. Some stations had wall-mounted maps with pins showing where each known voice had been heard last. It was part intelligence work, part detective work, part acoustic archaeology, and it required a kind of memory most people don't have. The linguists had to learn the enemy's voices, not just the language, but the rhythm, the timbre, the idiosyncrasies. They had to recognize a speaker from a 5-second transmission through heavy static. They had to distinguish between officers who sounded similar, remember which units those officers commanded, and infer meaning from changes in tone or urgency. It was, exhausting. Shifts ran 12 hours or longer. The listening stations were isolated, mountaintops in the Aleutians, atolls in the Pacific, requisitioned estates in the English countryside. The work was classified beyond classified. Linguists couldn't talk about what they did, couldn't tell their families couldn't even tell other service members unless they had clearance. They sat in rooms lit by dim bulbs, headphones clamped over their ears, transcribing voices of men they would never meet, in languages most Americans didn't know existed. Some broke under the pressure. Reports from Pacific stations mentioned linguists requesting transfer, citing nervous exhaustion. Others pushed through, driven by the knowledge that their work mattered, that the convoy they helped locate wouldn't reach its destination, that the bomber group they identified was intercepted before it hit the troop ships, that somewhere out there, soldiers who would never know their names were alive because of a word pulled from static. But even as the filtering technology improved, there were intercepts that remained impenetrable. Transmissions so badly degraded that no filter, no spectrogram, no trained ear, could recover them. The engineers knew why. The problem wasn't just noise, it was information loss. When a signal traveled through enough interference, parts of it were simply gone, erased by fading, overwritten by static, absorbed by terrain. No amount of filtering could reconstruct what wasn't there, so they tried a different approach. Instead of trying to hear every word, they focused on hearing key words. Intelligence officers and linguists worked together to identify the vocabulary that mattered most. For Japanese naval intercepts, that meant ship names, coordinates, fuel status, attack times. For German Luftwaffe traffic, it was target designations, altitudes, formation sizes. For Italian coastal units, it was convoy routes and minefields. These words became the priority targets, the fragments that, if heard, could unlock the rest of the message through inference. Linguists were trained to listen for these anchors. Even if the transmission was 70% unintelligible, if you caught truck, 0600, and convoy, you had enough to build an intelligence report. The rest could be guessed, cross-referenced with other intercepts, or left ambiguous with a note for analysts to interpret. This strategy required trust that the linguists knew the difference between a confident translation and an educated guess. Trust that the intelligence officers would weight the report appropriately, act on the solid parts, investigate the uncertain ones. And it worked, most of the time, because the people doing the work understood the stakes. They knew that overconfidence could send planes to the wrong coordinates, but that excessive caution could mean missing a target entirely. The balance was delicate, and it was recalibrated every single day. By 1944, the Allied voice intercept network was operating at a scale that would have been unimaginable 2 years earlier. Hundreds of listening posts, thousands of linguists, millions of hours of intercepted audio. The infrastructure to support it had grown in parallel. Secure communication lines to relay intelligence from remote stations to command centers, courier networks to transport physical recordings, administrative systems to catalog and retrieve intercepts from months prior. And the Germans, Japanese and Italians, knew they were being listened to. They changed frequencies, used brevity codes, rotated call signs. Some units went to radio silence entirely, relying on couriers and landlines. But silence itself was intelligence. If a known unit stopped transmitting, that suggested they were preparing for something, an attack, a withdrawal, a regrouping. The absence of a voice could be as informative as the presence of one. In response, the Allies got better at finding transmissions. Direction-finding networks triangulated signals, pinpointing the location of transmitters with increasing accuracy. If a Japanese carrier group maintained radio silence, but a single weather report was sent from somewhere in the Philippine Sea, DF stations could narrow its position to within a few dozen miles. That was enough for reconnaissance planes to search, enough for submarines to set up patrol lines. The engineering behind direction finding was as sophisticated as the filtering technology. Rotating, loop antennas that could sense the orientation of an incoming signal. Multiple stations coordinating their readings to produce a crossfix. Corrections for ionospheric refraction, terrain effects, and propagation anomalies. It was radio engineering pushed to its limits, operating in real time under combat conditions. And when it worked, when a DF fix, a filtered intercept, and a linguist's translation came together in the same hour, it was devastating. Japanese supply convoys that never reached their destination. German bomber formations intercepted before they reached the coast. Italian minefields mapped and avoided. None of it was guaranteed. But all of it was possible because engineers and linguists had learned to fight in the invisible spectrum, where the battlefield was measured in kilohertz, and the weapons were patience, precision, and the ability to hear what shouldn't be hearable. Then came the test. June 1944. The Allies are preparing for Operation Overlord, the invasion of Normandy. The success of the landing depends on surprise, on the Germans not knowing where or when the blow will fall. And that means the Allied intercept network has a new mission, not just to listen, but to deceive. In the months before D-Day, British intelligence runs Operation Fortitude, a massive deception campaign designed to convince the Germans that the invasion will hit Pas-de-Calais, not Normandy. Fake radio traffic is broadcast. Dummy tanks are positioned in Kent. Double agents feed false information, but all of it is fragile. If the Germans intercept enough real Allied transmissions, if they hear the actual units moving toward the real embarkation points, the deception collapses. So the Allies go silent. Radio discipline becomes absolute. Units use landlines and couriers, wherever possible. When radio is necessary, transmissions are brief, coded, and sent on frequencies that change daily. And critically, the intercept network is turned inward. Allied listening posts monitor their own transmissions, searching for breaches. Units that break protocol, operators who get sloppy, signals that might give away the plan. It's a strange inversion. The linguists who spent years listening to the enemy are now listening to their own side, hunting for mistakes. The filters designed to clarify Japanese and German speech are now used to analyze American and British transmissions, checking for weaknesses the enemy might exploit. The entire apparatus of signals intelligence becomes a mirror, reflecting back on itself. And it holds. The Germans intercept traffic, but not enough to see the full picture. Their direction-finding stations track Allied units, but the readings are ambiguous, deliberately so. Hitler remains convinced the main invasion will come at Calais. By the time the truth becomes undeniable, it's June 6th, and the Allies are ashore. The linguists and engineers don't storm the beaches. They're thousands of miles away, in stations scattered. Across England, Iceland, and the Mediterranean, still listening, still transcribing, still hunting for German reactions, troop movements, counterattack orders. And on June 7th, when Rommel begins pulling units toward Normandy, they hear it first. Officers shouting grid coordinates over static-choked radios, panzer commanders demanding fuel, Luftwaffe pilots reporting Allied air superiority. The intercepts are degraded, frantic, overlapping. But the filters do their job, the linguists do their job, and the intelligence flows upward into the hands of commanders who use it to adjust the advance. Block reinforcements hold the line. After Normandy, the voice intercept program only expands. As the Allies push across France, listening stations move with them. Truck-mounted receivers, portable direction-finding units, linguists working from tents and commandeered buildings. The front moves, faster than infrastructure can follow, so the equipment gets lighter, more mobile. Engineers design battery-powered receivers that fit in a backpack, filters small enough to carry in a field case, wire recorders that can operate in mud, rain, and cold. In the Pacific, the war is still grinding, forward island by island. Japanese forces are increasingly isolated, their supply lines cut, but they still have radios, and they still talk. Intercepts reveal fuel shortages, ammunition dumps, defensive positions. The linguists catch orders for banzai charges hours before they happen. They hear pilots reporting engine failures, destroyers signaling distress, garrison commanders requesting evacuation that will never come. It's grim work. The voices on the other end are desperate, often doomed, but the intelligence saves Allied lives, and so the listening continues. By the time the war ends, in 1945, the Allied Signals Intelligence Network has processed millions of intercepts. The linguists have heard thousands of voices, some repeatedly, some only once. They've learned to recognize speech through noise thicker than anything they trained for. They've watched the technology evolve from crude bandpass filters to sophisticated spectrographic systems that can visualize sound itself. They've become part of a machine, human and electronic, that turned radio waves into intelligence and intelligence into survival. And then, like most wartime innovations, it doesn't disappear. It transforms. In the decades after the war, the filtering technology developed for voice intercepts becomes foundational to civilian telecommunications. The same principles, isolating speech frequencies, suppressing noise, enhancing intelligibility, are applied to long-distance phone lines, radio, broadcasting, early hearing aids. Bell Labs engineers who worked on military filters go on to design systems for commercial aviation, for public safety radio, for the first satellite communications networks. The voice analysis tools evolve into forensic spectrography, used by law enforcement to analyze recorded threats and identify speakers. The techniques for recognizing individuals by voice, those carefully built profiles of Japanese commanders and German pilots, become the precursors to modern voice biometrics, the algorithms that unlock your phone when you say a phrase. And the linguists? Many of them stay in intelligence work, transitioning to the Cold War where the enemy speaks Russian, Chinese, Korean. Others return to civilian life, becoming teachers, translators, academics. They don't talk about what they did. Most of it remains classified for decades, but they carry the knowledge that once in the static and chaos of a world at war they heard through the noise. They found meaning in fragments. They turned sound into strategy. Some of the old listening stations still stand, concrete bunkers on windswept islands, Quonset huts rusting in the Aleutian fog, abandoned outposts in the jungles of the Pacific, their antenna masts long collapsed. If you find them, if you step inside, you can still see the mounting brackets for the old receivers, the cable runs in the walls, the ghost of a workspace where someone sat hour after hour, listening to voices, carried across oceans and continents by radio waves that bent through the atmosphere and arrived as whispers. They built these places to survive a war, to give linguists and engineers a chance to do impossible work under impossible conditions, to hear the enemy's voice clearly enough to understand it, predict it, counter it. And in the end, they succeeded, not because the technology was perfect, it never was, but because the people using it understood that clarity, even partial clarity, was a weapon, that every word recovered from static was a piece of the puzzle. That hearing the enemy meant knowing the enemy, and knowing meant winning. If stories like this remind you that wars are fought not just with guns and ships, but with sound, signal, and the people who refuse to let noise win, subscribe. Because the next one goes deeper into the systems we built to hear what we weren't supposed to hear. They built filters to cut through chaos, and those filters taught us how to listen in a world that never stops talking.